we are going to have a panel. Opportunities and challenges for semiconductor suppliers in regards to electric vehicles, including vehicle security, ADAS, lighting, infotainment, and powertrain solutions. I will be moderating the session. May I request Dr. Suken Deb Roy. May I request Jitendra Ashok from Infineon. May I request Mr. Jailendra Kumar, I think who is supporting from morning. Thank you for your inspiring questions as well. Mr. Uma Mahesh, founder and CEO of Innoterra Semiconductors, Innoterra Nano Systems. Bipin Chandra Pandey once again. Thank you, gentlemen.
Uma Mahesh, been part of semiconductor industry from the beginning. Have been fortunate enough to be part of different companies, getting to contribute something to the ecosystem. And currently, here I am as a part of Innoterra Nano Systems. This is a company we started in 2018 in Europe, Netherlands. I'm the co-founder of it and on the board of it. We make neuromorphic processor-based solutions for deep edge data processing. And one of our applications we are looking at is, of course, autonomous vehicle gesture recognitions and so on. So it's very exciting to be part of all of you and hear from you and share our thoughts. Thank you very much.
My name is Jitendra Ashok and I'm from Infineon Technologies. I'm currently the senior product manager there, managing NOR flash memories for the Asia Pacific region. I have been with Cypress/Infineon for the last 15 years, doing multiple roles in terms of project management, product marketing, regional marketing, and technical support. And I hope I'll be able to add some value in terms of the challenges we face in semiconductor supply chain, not only for electric, but in automotive in general. Thank you.
I'm Jailendra Kumar. I run a consulting firm called High Norm Systems and Services, out and out semiconductor and I would say high technology professional. When I say high technology, I mean semiconductor is a small system, complicated, high technology in larger systems, defense, security, and so on. I have been with the development of these systems all through. Lately, I have also been interested in looking at the techno-commercial side of it, the potential of those designs, potential of application of those systems. So I'm here to kind of look at this EV from both the sides, technology as well as application.
I should acknowledge just now someone said Namaskar, and it's the meaning that the big mind of mine be the big mind of yours. Similarly, I work for a Japanese company, and where you say sun, sun is similar to G, and Oskare samadesta hajimemaste. It's my great pleasure that I'm here on behalf of the company, and I would like to introduce myself. I am quite old in the industry, about 22 years. I started my journey for Fairchild Semiconductor, which is now On Semi. Then I shifted to Global Foundries. I was also Technology Innovation Manager at IISc Bangalore. At the same time, I'm also a product leader. And it's my pleasure that we are focusing now on behalf of the company on electric two-wheelers. The focus here is how we make the ecosystem being a partner, because we cannot do on our own. And that's why I'm very glad with my fellow panelists that we are component supplier, we are also tier 1, tier 2, as well as OEMs. And you'll know more as our discussion explores. Thank you so much for being here. It's my pleasure, Siva sir.
Thank you very much. There is a question actually, how many semiconductors does an electrical vehicle have? I think, I just Googled out, and currently it is around 3,000 chips. I think down the lane, probably in a couple of years, it's going to be a kind of a Moore's law. It's going to be 6,000 odd chips per electric vehicle. So that's a huge thing. From Indian perspective, we will explore how the things are there. Okay, so, and one more thing, compared to a battery electric vehicle, it will be twice. So if it is 1,000, let's say right now maybe it's around 500, 600 kind of things. Okay, and in terms of the volume of the business, the amount of global automotive semiconductor is estimated to be $43.6 billion, and it's huge. So even if you take 1%, 10%, somebody has put the slide saying that Indian current automobile market is third, and probably in 2030 we will be the third, fourth of EV market in the world. So that means the lot of semiconductors going to be pumped into India. I mean, definitely Ram and Infineon will be very happy to pump those things. So, and one more thing I just Googled out and I saw, like Tesla, everybody knows, right? So which is the main company supplying semiconductors? Maybe Ram and things. I found out ST Microelectronics is the one actually supplying to Tesla. I think if you bet on that stock, probably it will thing, and probably Infineon and Ram has to move further. Okay, so I just start with again with Mr. Uma Mahesh. In fact, Uma Mahesh is one of the founder of one of the first semiconductor company in India. That is Arcus Technology. A lot of people may be aware that TA is the first semiconductor company. That is the first semiconductor MNC. The first semiconductor design company is Arcus Technology. Today, what you see Infineon, today what you see Broadcom, today what you see, these are all, I mean, the mergers and acquisitions from Arcus. So he is one of the founder, and he is currently the founder of a neuromorphic technology. This is a different IC altogether. Probably you can give us a little bit jnana about neuromorphism and neuromorphic stuff, and how actually it can helpful for the, let's say, automobile segment. Any particular applications you have in mind for these products? Not necessarily EV, so could be any product. Okay. So we are just more interested on the neuromorphic stuff.
Good evening. Actually, I thought I'll talk something else altogether.
Anybody knows neuromorphic IC?
Okay. And,
no hands seen.
Good.
Okay.
So
it's a new technology. So let's hear from him.
Actually, I thought I will talk about something else altogether. Maybe I'll do in the end, possibly if I get an opportunity.
No, you are free to say,
Okay.
talk anything.
And,
sir, no problem.
After all the semiconductors people speak.
Okay.
But having said that, that's about a larger perspective. So that maybe I'll do in the end if you give an opportunity. But currently, what we are talking about is all the autonomous vehicles, electrical vehicles and other things, right? Everybody says finally, everybody agreed now that vehicles are going to be more of electrical and autonomous and so on, right? It depends on where all the value chain people will add value is important. And one of the most important things there are a lot of these sensors to be part of the devices, and that includes within the vehicle. And vehicle need not be four-wheeler necessarily, it can be two-wheeler also. And also how when it is going on the road, how it interacts with the ecosystem, maybe the signaling system, maybe the next vehicle, maybe the control system, so on and so forth, right? So idea is the vehicle should interact and react faster than where they normally are, so that there is no processing delay and corresponding disasters are prevented. So one of the things we look at is any sensor data, sensors are primarily analog, and any sensor data first comes, it has to be processed, and then it will all be aggregated later by various companies. The world is talking about all that. But where the data is generated is essentially called an edge, and so far wherever it is being processed is called cloud typically. But when more and more data gets generated at the edge, it also needs to be processed there and corresponding decisions to be taken while forwarding the data forward. So if you look at anybody, they all talk about we are in edge processing and so on. But most of them, what they do is aggregating the data at the edge. That is interface between the edge and the network layer, and they send it outside. Very important, no doubt about it. But they need to get a data from the sensors, which are on the, I would say, if the edge is more like a band, so the left edge of it, if you draw on the board. So take the sensor data and correspondingly process it and give forward to the aggregators. And the sensors are more than not analog. And which means you need to process it, deep edge processing means at the fastest possible and with the least latency. So which is the fastest processing engine, which consumes the least power, and this is one thing which the entire world agrees, which I think all of us have, which is the brain. So idea is you make a processor like brain, that's called neuromorphic processor, and process all the signals based on neural network algorithms, and that digitized data will be used by everybody to take decisions. So we do the neuromorphic processing like brain, and which means we have a processor which is analog, which is like brain processing. which is the least possible power consumption, sitting next to the sensor, gets integrated into the sensor and so on. So yes, one of our first applications, sir, we are planning is, suppose, we believe that these all will be required in the market if you look at Gartner and others, 25, 26 and beyond, which means our customers are, end users are all of us, but our customers are supposed to be, among others, the automotive companies, which means the semiconductor people who give to the automobile company, including our Infineons and STs of the world. So we provide our chip or our IP to them. They correspondingly make the solutions and give it to the customer. That is the plan we are working on. One of the first thing we are looking at is audio and the gesture recognition. So when you look at as an automobile, when you sit inside, you move your hand, something should happen, and it's a quick, fast recognition. It's one of the first thing. We use sensors like lidars, and we are not the normal IR sensors and other things. So that's what we have the solutions ready. We are working with the customers, including the silicon customers, to work on that. So that's what we are doing right now. So yes, we will be part of the e-mobility part of it definitely, but looking at these aspects of within the car and how the communication will happen outside, because the human interface being faster and quicker and accurate. So we'll talk more about other things later. Thank you very much for that, sir.
Yeah, thank you. So that gives a lot of interesting things. What you are saying is low power, high performance. So yeah, and at the edge. So probably it's going to replace the edge processors and things like that.
It's the deepest of the edge and the least power consumption. Talking about nanowatt, microwatt, milliwatt type of thing. But you have to aggregate the data further. You require all the edge process, Intel, ROM, everybody will all be required. But they need to data from us to integrate further.
Okay.
So we will definitely be the first step, because they can't take data directly from the sensor,
Okay.
but they require us.
Okay.
So
So as you said, maybe you may sell your IP or product to Infineons or something like that.
Possible. That's
I would
always
like to hear
possibility.
from Infineon. Definitely, when the processing is done by the, let's say, neuromorphic or this Open 5 and any of these processor, high-end processors. So definitely, there is a lot of memory is the key game. I think you hold the memory division as your prime FSA. So you can tell about what is that Infineon is working on, particularly this memory technologies, or
Sure.
how may it will
Sure.
again to automotive side, if anything.
Definitely. I think, like he was already mentioning, we see number of mega trends that we call it, right? Autonomous driving or assisted driving, electrification, and connectivity. I think these are the three mega trends that you look at. And all of them require more processing and more processing at the edge. If you look at autonomous driving, you need to make decisions at the edge so that there's a prevention of any fatality or anything like that. And then electrification also requires a lot of processing. And all of these have an additional complexity that requires over-the-air updates. So whenever anything's becoming smarter and is connected to the web, then you require over-the-air updates, and which means that you need external memory to support these high-performance requirements, as already mentioned. So we are working on multiple things, and for us, two predominant things that we work on, and I'll talk about it a little bit more in detail later, is obviously functional safety. I think functional safety is becoming a term. Electric vehicles are also slowly understanding the need of functional safety in this market, right? I mean, ICs are already required, whether it's ASIL, B, C, D. And then even from at a memory component, customers are asking for a higher level of functional safety for those components. Then security. Now, what level of security is enough? I mean, anybody will say there is no enough level of security. But at the end of the day, we need to understand, as we connect more, you get more hackers in play. You need more people who will come in and try to steal data, replace data. And we've seen a lot of even Teslas, for that example, getting hacked. So how do you prevent all of that? And we'll talk a little bit about what Infineon is trying to do in putting security modules into the memory chip. So this is a new way of protecting data, not only at the microcontroller level, but also at the external memory level as well. And finally, as we go down the process node, which Sir was talking in terms of going down from 28 nanometer, 22 nanometer in terms of the microcontrollers or the microprocessor, you cannot embed flash anymore. And hence you need to have a high performance external memory. So that also we are looking at. So as the car or the vehicle becomes smarter in terms of having smarter clusters or an ADAS system or a electric vehicle train, battery management, traction inverters, numerous applications now are getting smarter and hence need more memory on the outside.
Thank you. I'll give it to Dr. Sukendev, right? In fact, I just going through your profile and it's very interesting stuff. Actually, you are from physics background, did in lasers and did at Sense and in Global Foundries. I think whatnot. I think you touched the physics of the semiconductors completely, and now you are more into the power electronics. So probably the analog part of it. I think I would say you are the master and jadoo of physics and analog. So we would like to hear from you. Okay, so one is the processing, new stuff is coming, memory. The new data is taking and security is there. What is this RAM will be doing in terms of the power, taking the power controls and things like that? Any other general perspective, if you can think, if you can share with us?
Yes, I would really share. And one very important thing which everybody I would feel should know, that we make products for the customers. And that's why customers inciting the very first step, then developing technology. That's the very thing I learned from physics background, that we are onto physics and technology, but as long as making product, we never think of the customers. The first thing.
Just to interrupt you, that's very interesting. That's the Japanese style of saying if they are particular to one thing, they will say we are developing for products for the customers. But in MNC, like from companies like US, they develop products and they develop technologies and they develop customers. I think that's what number one, number two, number three, who are semiconductor companies, what you see, they develop products irrespective of the things, whether you want 5x or 6x. They develop continuous technology and then to customers. They develop customers afterwards. Right now what you are saying is you want to give the solution to customers. So that's it. Sorry to interrupt you.
Yeah, thank you. I think you elaborated to a greater extent. But what I am trying to say to everybody, that every learning should start from the end users. For example, I give a very, very typical example. If you're looking for two-wheelers and you are making helmets, but you make helmet space for two person, for me and for my girlfriend. That's the kind of insight you need when you build your product, even for you're talking about helmets. So coming to the same background, I would say the first insight that I found, that we first think about the end users and try to find other pains and how we can solve their pains through our technology. The second part is a very, very difficult to tell, even for a Japanese company. All those who have learned just in time, lean and thin, is not working anymore. Do you see all those accumulation of inventory that is happening, and that's giving a spike and inventory? That's really difficult in lean and thin technology. So we are talking in a different terms. What is the need at this point of time that should be considered? The third point is that we are a company to make products, and we make impact through our products. And that's why we have to make products which should sell. And to sell, again, we have to come to the customer. What do you really need it, and can we help together? And that brings the fourth perspective, that we have to solve together. We are in an ecosystem we cannot do on our own. For example, we have our presence Rome as a tier 1 company, tier 2 company, supplying components to the module. And module goes into the system. But we cannot build on our own. We have to go to the right people that this is what we have. And that's why collaboration is the biggest key. So these are a few points I learned through my experience. And more important that, in order to understand the ecosystem, you should have a T-shaped kind of experience. One depth, which is your strong point of technology, and then you take other areas of overlapping, which would make things learn better. Then you can deliver the best.
Okay, thank you. So probably I'll just pass it over to Jailendra. Just want to tell you, we have 3 IITs actually. He is from, Jailendra is from IIT, alumni of IIT Mumbai. I think Shukendra is from IIT Delhi and IIT Chennai.
I'm the only one not from IIT.
Me too. I'm just from NIT, not NIIT, NIT. Okay. And just to tell about Jailendra. So he is the first head of Samsung Semiconductors in India, and he is one of the first head of British aerospace systems. And he also worked with Philips Semiconductors. Whatever we are seeing, the USB technology, he actually probably his algorithms or his VLSI code went into our USB sticks, whatever we are doing it. He was the first development manager for that years. So I would like to hear from you. I think when I was talking to you in the morning discussion, probably if you want to give us more about general EV kind of what I think you have something to share with us. I have not given any special thing, so probably you can take this opportunity to tell about EV, whatever you feel, and then come to back to semiconductors.
Fair enough. Thank you. Thank you, Siva. It's interesting that since morning we have had, I would say, about dozen sessions, each one talking about the strength of their company, their work, which was natural. I could speak on semiconductor. I've done work on semiconductor too, but glad that you're taking a slight detour here. I want to take your thoughts on a little higher level of the industry, which is EV in general. So, some observations from today's talk, today's sessions. Out of about dozen sessions that we had, vaguely recall how many were on the battery and BMS. Was it a clear lead over all other subjects? And what was the reason? See, when you're used to this combustion type of vehicles, IC engine vehicles, the engine and the engine control was barely about 30% of the cost of the manufacturing of the vehicle. When you go to EV, you're talking about 64-65% of the cost only in the battery and battery management system. This was not the plan. The sessions were not planned on this statistic, but it happened to be that. So obviously, where do you need perfection and optimization? Where your cost outlay is more, obviously. Battery as such is not semiconductor, the edge of semiconductor that my panelists are talking about here. Of course, semiconductor in a sense. How about the other things? Today, we are able to sit here and talk about this simply because it has gained some momentum. EV today has gained some momentum, and that's why we are having a discussion on this. Was it easy to go from an aspirational petrol car, diesel car to an EV vehicle? What if it hadn't taken off at all? What were the factors that made the EV to take off in the first place? Okay, I have the technology, I have the battery, other body, vehicle body, and so on and so on. Was it enough reason to establish what I call a complete alternative industry, alternative product? When you think about it, you will figure out that whenever you are trying to disrupt an existing industry and create a parallel substitute industry for the same application, for the same product domain, you need to work with all stakeholders of that industry. If I have to think of the main stakeholder blocks for this EV, let us put three for simplification: the manufacturers, the users, and the service providers, people who will allow you to charge your battery and all other services. So it was necessary that we made noticeable strides in all these dimensions of the industry, and that required not only technology innovation, it also required significant financial risk taking by the entrepreneurs and also parallelly working together, lots of policy support from the government. So whichever country, whichever government provided support, that is where EV is thriving. It was not possible without that government support. So, okay, let us look at the government support in India for that matter. Government gave manufacturers the subsidies, the incentives. Government gave users tax breaks for buying the vehicles. Government allowed again subsidies and incentives in whatever form for setting up charging stations, even sometimes leading the standards local for India. So when you talk CCS, when you talk CHAdeMO, you also have parallel Bharat 001, Bharat 002 standards for charging here. So now, so these things kind of set up the basic building blocks for the industry to stand on it. Once the industry is now able to stand on its feet, you are able to now see very, very fine pieces of contributions coming from the companies. For example, when you say battery, then BMS, then you are bringing safety into BMS, then you are bringing battery performance at the pack level, then you're talking about battery performance at the cell level, etc., etc., etc. So I think I will stop here this digression, but I think when we talk next, we should talk about how the electronics and semiconductor, although let me warn here one thing. In the overall product cost, the whole day we are spending about semiconductor and innovation in that, but this is very, very small percentage of the product stack up, cost stack up. Yet the promise is here. Promise is here. So let us talk about those things in detail now. Thank you.
Yeah, that's true. So we are not talking only semiconductors. Probably this panel is semiconductors, and I think probably we have been talking about inverters. Even we have subjects based on chemicals and things like that. I'm not limiting this to only semiconductors. I have only a couple of questions. First question probably to Ken. General thing is we have been talking about fab, and we know there are a lot of buzz is happening, and we don't know really when it's going to come up and things like that. I have my own thoughts about that. My question to you, because you are from the fab background and things like that, physics background, worked in fabs, including sense in ISC. See, CMOS technology, 7 nanometers, 10 nanometers technology making in a fab, that is one thing, okay, that when we are going to get it and all. But to make a power electronics, I don't think you need such kind of technology as such. Is it really an impeding factor from Indian companies, or do you think there is no, I don't know whether you have that kind of data. So maybe Infineon can also give the data. There is huge, because India is a very huge automotive market. So definitely there will be automotive semiconductors. And somebody also suggested, I think from Rama, somebody that silicon carbide is one is a thing. Maybe gallium nitrates. So many technologies, I think, which is sense is working. So my question is, what stops us Indian companies to get into that kind of fabs? Pure analog fab. Pure power electron. Come out with a good MOSFETs, good things. Why not? This is this question is lingering to me quite for some time. You have anything to tell, or Jailendra or somebody can take it, this question?
Yes.
So this is, I'm not talking about the fab, what people generally talking about, $1 billion. I'm just talking about the fab for the power electronics and analog stuff. Yeah, you can take it.
I think there are two parts of your question. First, you talked about power electronics and then the fab. So I'll first talk about the power electronics again. To be very frank, we have been looking for professionals in power electronics. We are still yet to find them. A good power electronics guy still we are not finding. The reason is the focus is different. We do into product making, but designing a MOSFET is still a high end. So much of changes has happened, especially of 4 reasons. One, when you are using power MOSFETs, you need high current capability, high current density. We talked about thermals. All are new designs, and that's why we need professionals who are good at it, which Indian ecosystem is not able to provide. And it's very unfortunate. For last 6 months, we have been looking for power electronics guys. We did not find them because the ecosystem is not supporting to bring a power system design guy as a device system, which is the bricks of the whole building. If you look at building, the bricks are the building block. Similarly, MOSFETs is the building block for those. That's the first question. Next comes about the fab. It's very easy, and that is a lot of hype. And if you look at the policies of the government, the important part is wide bandgap gallium nitride, and it is 20 nanometer technology. It is not power electronics. The reason is having a fab requires a supporting ecosystem. For example, if you have a power supply, if something goes wrong, someone has to repair it, and the equipment comes from elsewhere.
Just stop to you. I'm not asking about the fab ecosystem. I'm just pointing towards to the fab for the power electronic stuff, which I feel may be less complicated, less technology oriented compared to a big $4 billion fab.
Agree.
So for that, it may not require that much complexity, which I feel. I may be wrong. So maybe maybe
Yeah,
Chetan,
I'll
you
just
have
add
some idea about it.
some points, right? Obviously, talent shortage is a big driver. But having said that, if you look at the automotive or the power, any semiconductor market, right, till 2017, 2018, the demand for semiconductors was not as much that required additional investments. Now, and the demand suddenly skyrocketed after COVID because of the increased usage in a lot of applications,
Yes.
automotive, for example. And that has now created a demand versus supply gap. Now there is interest to build semiconductor fabs. Yes. The first thing is, do we have the infrastructure? And now government has come up and saying we will provide the required infrastructure. I'll give you an example. Like we have a fab in the US. Due to the cold wave in Austin, the power went away for 3 seconds and we lost a complete set of wafers. So, in order to set up a fab in India, we not only require power that can be guaranteed 24/7, then all the other infrastructure in terms of water usage, manpower usage, and then the corresponding structure or ecosystem in terms of supply and demand for the raw materials, etc., to come into the play. Today, we do have 3 companies who have shown interest to set up fabs. And we do hope even companies like Infineon are looking forward to get fabs and maybe at a higher nodes. It doesn't matter because the usage of, like you said, let's say the 28 nanometer or the 14 nanometer or 7 nanometer is still in a consumer play.
Yeah.
It's very less into the automotive space today.
Okay.
But it is going there and hopefully we can ride that wave.
Okay. Okay. So anything to
Yes,
add from your end?
Let me add something.
So,
So
1 minute.
I agree with you.
Yeah.
I agree with you that there is a case for having a local fabrication facility in India.
Particular to the low end. I'm not looking for the
Particular to
high end
low end.
fab. So maybe you
But
can.
to partially, I also agree with Sukhendu. So last year, how many vehicles, I'm including 2-wheelers, 3-wheelers, 4-wheelers, were sold in India? You have any idea? 4 lakh plus 4.3 lakh. I mean, which is 430,000.
Yeah.
There are some people who don't understand lakh here.
Okay.
430,000. Now, a rudimentary motor driver for 2-wheeler, each motor will require 4 MOSFETs in a 2-wheeler case. So, assuming that all 430,000 were 2-wheelers, you are talking about 1.7 million MOSFETs. So, his point about do we have market? Is there a market pull? Answer right now is no. But are you going, if you set up something today, are you going to have the MOSFETs churning out from the factory tomorrow? No. So by the time you are able to churn out, what will be the market? And what is the rate of growth? So post-COVID, the growth has been 200% in the EV. So I have hope that we need that and it should happen. All right? You also made, Sukhendu, one point about people, the skills, scarcity of skills. I would again say that it is like with due respect to you, we as the industry leaders in some way, it is not good enough for us to pass on the buck. Unless there is a skill, I can't take up this project. I cannot take any entrepreneurial journey without, unless you give me the 1, 2, 3, 4 things. It goes hand in hand. Way back about early 2005 or 6, so which was 17 years ago, we had carried out a study in India, and we figured out that there were totally 1,100 VLSI engineers in India at all. That's all. Working for MNCs who were only designing India, not producing in India. What is the number today? How did it come about? It came about because there was a two-way process. There was a demand, there was a need from outside world to get into India and do this. We showed by our good work, by our results, that we can do a great job. So it goes hand in hand. So I am an optimist, and I believe that the journey must continue. Think of 10 years ago when EV was just a concept. Today it has taken shape. You have so many participants exhibiting
I
here.
got it. So, surprise. Sorry to interrupt you. I understood. I think as industry leaders, I think we also should contribute to the things. I think more or less directly or indirectly we are doing it. My another question is the fab was related to the analog and power electronics. I'm just going a little bit down. Even the EMS manufacturing. Even in our previous company, when we want to develop a product for railways, Indian railways, a PCB, right? PCB manufacturing has to be done. We found it's a 6-layer board. We say 40 layer doesn't mean that it's only layer, that is a stacking of the layers, but the precision of the layer, the thickness of the pitch, I think that kind of technology is also not there in terms of PCB manufacturing. I really wonder, when we don't have such kind of the PCB manufacturing, forget about the fab. So are you come across such kind of things? People, I think your customers are developing products, and probably still they are developing the PCB manufacturing also outside. I'm not talking about the cost, even the prototyping also.
Let me add, it depends upon industry focus. Right from the beginning, our focus has been BLSI. Design center in India, thousands of professionals who had been trained into VLSI. And there was not much of focus on power electronics. This is what I'm referring to. Now that we need power electronics, that we increase attention creating those professionals. And it is possible. I would summarize this as small, because others I would like to have.
No, I think definitely we did see challenges, I think early 2005, 2010 in terms of PCB. But I don't
even now. I mean, just talking about 2 years back, when not last year, but I found the good PCB manufacturers are not there. I mean, I don't know.
there are few, but yeah,
Yeah.
maybe not too many.
Okay.
Again, I will take a divergent note.
Okay.
When-
1 minute. Yeah.
When companies in India can create the prober PCB interface, I cannot take on face that we cannot have the good quality PCB. You understand what I'm talking about? Prober PCBs, which are very, very, very minute, very precision PCB designs. So when we can do that, we can do this as well.
So one more last question from my side. We are talking about semiconductor, shortage and things like that. It's a general thing. Even I think I'm sure ultra fast charge is developing tomorrow. A lot of products definitely has to be imported from the outside, and the scarcity of those semiconductors will definitely affect Indian design houses from Infineon or any of such kind of thoughts you have. So do you ensure for the Indian designers, do you say that बाबा ये तो इतना स्टॉक हम दे देंगे इंडिया को, ऐसा कुछ है क्या? I mean,
ऐसा पॉलिसी तो नहीं है.
होना चाहिए ना. So see, we
That's
cannot
true.
be at the mercy of the things.
No,
So,
I think
you are taking a lot of talent from India. I mean, talk about Infineon as such.
I
So-
agree. I agree, and we have also been thinking. So
Yeah.
there is a preference to sample.
Okay.
So in terms of sampling, I think whether it is in India or worldwide, I think sampling gets the highest preference because that drives new business. And that I'm sure all companies, your Rome or ST or Infineon, all of us do support. And now that the while the industry is still under allocation, some portions of the industry, there are some segments that have gone out of allocation. A lot of parts are also on lead time, and we are seeing more and more going towards lead time in the next year. I think we should be normal, and because of that, we are getting better support for all our Indian customers as well. The supply situation has improved, and we will see that going better in the next few months.
Sir, I believe 80-20 rule still applies. When you talk about customers, you'd see how much is the return of the 80%. And that's the preference. When we are talking about demand, we see the allocation needed for at least 80% of the top customer first, because that's how it drives our business. And then at the same time, make allocation for the next 20%. So 80-20 still applies here.
Problem is real. Scarcity has been world over. And that highlights to one simple observation, which otherwise we do make that observation. We don't put our attention on that. Once you have a single source of supply and any disruption in that single source, it will affect all of us. You know what I'm talking about, and that is a lesson enough that you should create your competency in all in geographic diversity, in segment diversity, and so on, so on. So that is real, but it is starting to ease out now.
I think, I mean, on the lighter note, what I observe is, even let's say my phone, if you want to buy the phone here, last year the price is less, now the price is high. I mean, even for the scooter, if you want to buy a 1 lakh rupees, now it is 1,20,000. Car is, so nobody's, the salespeople or the people are telling, it's not that semiconductors, the rates are increased. They're telling GST is increasing. So I don't know whether it is a joke or real. So because of GST, my rates are increasing. Anyway, on the lighter note, so I'm just throwing to the audience, I think Mr. Satish from Hyderabad, all the way from Hyderabad, I think he is developing his own vehicle, I believe.
My question to the panel, right now we are talking about, the processing, data processing happening in edge. Like, will it be good, if the same is happening in edge, or it will go to process somewhere and then coming back to the vehicle will be good?
And you got it, question?
Yeah. See, right now,
I understand. Yeah.
the data processing.
If I can answer a little bit on that particular thing, I think the edge what he is talking about is when you are taking the data at the sensor level.
Yes.
So normally we collect the data A to D, and then you are getting to the processor.
Right.
There is a difference.
The latency.
So it affects how much data. The more and more data if you take it, and they keep coming and processing here.
Yes.
So it will take more time.
Right.
So that's the whole reason the edge processing is coming in.
Edge
processing at the lighter level. That is what neuromorphic is going to replace at the sensor level.
Right. What I mean to say is, recently that there is NVIDIA Jetson.
They are talking about here.
Right.
Not at the. I don't know about it. I think you can give it to the
NVIDIA Jetson.
He's also talking about
Orin platform. They are processing in the edge. What they mean to say is, like, it will give better results than processing somewhere else and sending back to the
Very true. Actually, it's very simple, sir. Basically, edge is no longer a line; it's a band.
Right.
Okay, because so much people are into that, right?
Right.
Now, if you draw on the board, there are two lines to it. One is on the right side, which is connecting to the network layer and going outside.
Right.
Aggregation part.
Right.
Lot of these people are playing there. Very important. What happens is, when most of us have Alexa and all those things, right? Suppose you say play this song.
Yes.
Now there's a delay.
Latency.
That latency has to be reduced. So particularly when you're talking about automobiles in particular, the decision making has to be extremely fast. That means you can't wait for the data to go somewhere and come back.
Right.
That's why everybody is talking about edge processing. That means the data has to be processed then and there itself.
Right.
But there are two angles to it. One is the data generation part of the application part. Suppose you are in the car.
Right.
Okay, you say increase the volume, change the
Right.
channel, you do from the backside. That's application, right? And then it should do something about it. So that entire part is the edge. So what they do, and Intel, so many people do this, aggregating it and doing it there itself. But this data will still go outside also for a lot of data processing and other purposes. But everything will be locally within. That's why the latency has to be very less.
It
That's
does need to be
There's
reduced.
other part of the data, which is security, that goes to say, that goes on anyway to the other part of the data. One is the infotainment within the car, other one is outside the car. That part anyway will go outside. But within this, we need all these protocols to work, and that's why the edge processing and latency has to be reduced.
Thank you.
Thank you, sir.
So I have three inputs for whatever you are discussing. The first one is what you are asking about. For 28 nanometer, IMEC has already signed agreement. Okay, for the fab.
Okay.
Okay, so that is for your question.
Come again, sir.
You are looking for what is the fab happening in India for maybe for power electronics, analog, mixed signal
Okay,
things and all.
Okay.
So you know about IMEC.
Yeah, I know.
IMEC is in Belgium, one of the
True,
one of
true,
the
I know.
leading companies and all.
Yeah.
They have signed agreement in India, and soon we are going to be that fab. So that is the one input from your side, and for their side, for anything which you want to design, first should be designers. Designers should be your first input. So, like in our case, when we are designing, say for DC fast charger, first should be engineers. So design engineers, so top-notch design engineers. Unless top-notch design engineers are there, no product can be ever manufactured in India. So many times we thought that lot of policies in government, people thought product is first. Product is not first. First is designers. So if India are not having enough designers, whether it is for the software, hardware, power electronics, whichever field you are talking about. Okay, even if you are edge processing, whatever you are saying. So unless you are having a top-notch designer, top-notch means top 1% in the world. That type of people you are having in India, then only you can have. So that is my second input for this thing. And regarding how we have to manufacture. So you know Foxconn. Okay, recently I was having discussion with Foxconn. How Foxconn does it. So Foxconn is in Saudi Arabia today, and they are going to make electric cars. Okay, there are only two inputs.
Yeah.
If anything you want to do in India, only two inputs are required.
And
Okay, supply chain, super supply chain. Super supply chain nobody has in India. Okay, presently. So that is a big shortage. You don't know what is called as. So whenever you are saying Apple, so it may be whether it is small or big.
True.
Okay. So I'll just tell you, say for example, simple thing, I'll just give you an example. Suppose you just want a screw, M4/8, just a screw. Anybody can do in India, but I want 5 million screws today,
That's true.
every day. Nobody can do in India. That is what kind of Foxconn does. And the first part is super supply chain. Second is super efficient workers, okay, who can sit on your seat and work for 12 hours. So these are the three inputs. So if India wants to do any product, suppose I think for many people I have discussed, you want to make a smartphone. Okay, what is required for a smartphone? Anybody wants to do. First thing, top-notch engineers. If top-notch engineers are there, you can never make your designers mean everything. Okay, including your semiconductor engineers, software engineers. That is one. You have a super supply chain. Okay, in India. And last is very efficient workers. So this is all my inputs.
Yes. Thank you, sir.
You're talking about system level understanding. When you talk of top levels designer, that's I agree. But when I'm talking about product that is built first to be understood for whom, and then go from system level top to bottom. In a overview, first we understand what is the overview, and then say 100 miles top, and then go. This is what they're referring to. But still, product is for the end users, and system level understanding is needed. Power electronics does not work in 20 or 28 nanometer node. We still work in micron, and there are a lot of possibilities.
Yeah, I think one more question is there.
Hi, I'm Kishore Kulkarni. I'm referring to sir's comment that I'm taking a detour. So 65% of the discussion, over here it's 90% of discussion is about semiconductors, battery and battery management systems. But when you consider an EV, what is happening in India is 90% of OEMs, let it be a two-wheeler or a bus, they are retrofitting it.
True.
Nobody is thinking out of battery and electronic systems. Do you think without working on the peripheral parts, okay, we can achieve what we want in EV sector in India? Because I am coming from a structural background, sir. I'm a chassis supplier, okay. So do you think can I use the same 55-ton diesel chassis to a EV which is running on a DC motor?
Yeah, I may not answer you on the technical side. On the lighter note again,
Yes.
what I understood is EV may. I mean, the thing is, the heavy engine is not there. Okay, only the battery which is going down. So you have lot of flexibility on the mechanical stuff, and you can design whatever kind of style you are.
No,
I think
sir. I'm
mean,
coming to the
I'm just telling
point.
the lighter note. I'm telling.
Yeah.
So that the structure
When
side,
the-
EV side, I think that's a fantastic opportunity for you actually.
Yes,
So-
we try to do the more efficient chassis, which will reduce the weight. That
I
in
think
turns
that's
increase
that
the
is-
range.
I think that is where I think India actually can do it. Maybe anybody can. You can, Jailendra.
Okay, I'll respond to you. So I'm not the spokesperson for ACMA, but you know ACMA, right?
Yeah.
Right. And I read somewhere that they have a good practice. There are more than 800 members of ACMA, and if there is an inquiry for supply of a component, in fair play, ACMA gives it out to the relevant parties, and whosoever is capable, they respond, and they kind of do a matchmaking. Now, these are small players, and that is what we did not touch upon, that component business, right? Component segment of this EV. But I'm very glad to read that the ACMA is doing exactly that, facilitating, and there are small players. Even government is providing subsidy PLI subsidy as long as you make a turnover of 25 crore. So that means from the policy side, it is fine. From the association of your manufacturers, it is fine. Perfection in the chase, what you are saying, engineering thing, I think people like you will have to take responsibility to come out with those new designs.
Yeah, sir. Just to add on to you, we are the part of ACMA, and globally we are developing for Nikola and Tesla. In other part of world, everybody is focusing not only on battery, all the other systems, and they are developing as a new EV vehicle, a new vehicle rather than a retrofit. So in India, we would like to.
That is the whole problem. That is why you are seeing a lot of things are burning out and all those stuff actually. I mean, we electronics PCB ban gaya, EV ban gaya. That is a big problem in India actually. So it is like making one PCB is becoming a EV. It may not be. It is not actually. I think you are right.
Good one. Yeah, good.
Thanks.
Good thing. So that's an opportunity for anybody.
I am from TVS Training and Services.
TVS.
Yes, TVS Training and Services.
Okay.
So first I finished my IC engines master's degree. Then I have worked with Audi as an after sales department diagnostic engineer. Then I worked with wind turbine blade composites. Now I'm handling electric vehicle trainings. I'm getting GETs. They are freshly coming out from colleges. They have this big issue that what not things I should not study. Like we are reading MOSFETs, we are reading IGBTs. Like when we see this as an whole electrical vehicle system, it's not a simple thing like when it is 30 years before, not only mechanical things or not only electrical things. Now everything has become a bigger ecosystem. And in one way, I have to thank Infineon because I have acquired a lot of study material from them, course material from them. If a lot of manufacturers become more transparent, then I feel the knowledge gap which you are feeling will be fulfilled faster and will be.
So what is the question you are going to ask?
So the question is how much transparent this industry in this today environment to the newcomers, especially not to the experts.
For the EV or semiconductors? This panel is for semiconductors.
The technology I am speaking of, the technology provision to the academics or college levels.
I think quite transparent. I don't see any problem.
Say, let me answer this question. Whenever any product being developed in any of the companies, the first thing is the data sheet that contains of all the technical details along with the white papers. So if you go to any site on any product, you'll find it. They are very transparent because that's the whole business. Whatever we sell, we write it down. Documentation is a part of business.
So for your answer, if you want all these companies which are talking about Infineon, ST, Wolfspeed, ROM, they are having very good reference designs.
Yes.
Okay, reference design for all the converters, whether AC/DC converters or DC/DC converters. You can even have the PCB as a reference design, software from reference design, and that will be the first your beginning training. It is available online. I don't know. I think all the
Yes.
companies.
Yes.
Infineon, I think 11 kilowatt DC/DC is there.
Yes.
Correct. You learn about that. I will hire you. Okay.
That's perfect.
I think, thank you one and all. So, thank you. So, may I request Devendra ji come over and give the mementos to the people. I think you can, coffee is there. You can just go and I'm not giving any break. We are just getting into final session. Just pick up.